Okay, so welcome everyone to this second masterclass of the project Advancing Non-Conventional Water Management for Innovative Climate Resilience Water Governance in the Mediterranean Area, AG-WaMED. This masterclass is the second one of a series of masterclasses of our project, which is organized in the framework of the scientific dissemination. Today we will have basically three sessions. The first two, they will be on technical instructions for using the SWAT model, setting up a SWAT model, and then very important piece on calibration and validation. Then we will see some application of SWAT models in the dry areas of Mediterranean. Thank you everyone for your participation. My name is Giulio Castelli. I'm a researcher at the University of Florence, and before starting, I leave the floor to Professor Elena Bresci, who is the project coordinator.
So good morning to everybody. Thanks a lot for participating and for having shown us the interest on this subject. Just a few words because I really want to thank all those that have been involved in the organization. I think it will be a very profuse morning, and I hope you will get interest on the hydrological modeling application. And obviously, we as a group, we will be at your disposal if any doubt or something will occur after the masterclass. So thanks a lot again, and I wish you a very good work this morning.
Thank you very much. And now is my turn with a little bit of introduction about the project. I will take very little time. I hope you will find this useful to understand what we are doing. I think you should see my screen and you should see the PowerPoint. Just a second, I'm letting some participants coming inside the call. Okay, so I hope everything is clear. Please let me know in case it is not. And I'm going to introduce you. Thank you, Lorenzo. I'm going to introduce you the AG-WaMED project, which is a project funded by PRIMA Consortium in the thematic area of water management, and has a duration of 36 months. The coordination is at the University of Florence, and the project started on September 1st in 2022. We have a quite diverse and very specific group of partners, Polytechnic University of Milan, the Polytechnic University of Madrid in Spain, the Institute of Arid Regions in Tunisia, Alexandria University in Egypt, the Agricultural Economics Research Institute of the Hellenic Agricultural Organization in Greece, the University of Tebessa in Nigeria, and then very kindly the University of Amsterdam, which is participating with no budget because it's not from the Mediterranean, but their skills are very useful for us, especially for policy analysis. So which is the main objective of the project is to advance participatory governance for sustainable water allocation by integrating non-conventional water sources in the Mediterranean area. What do we mean by non-conventional water sources? We do mean water harvesting, wastewater use, desalination, and we are not only looking into the technology, but also in the water governance, the acceptance by the population, sustainable way of doing participatory water management, and so on. How in these and which are specific objectives? So the first objective, one of the most important, is to foster participatory and equitable water governance model for Mediterranean catchments. The second one is to innovate water resources and crop production systems modeling by basically including non-conventional water sources in models, also considering climate change scenario. And finally, what we want to do is to narrow the implementation gap between the European, national, and international rules and societal and institutional compliance. So basically what we want to do overall is to have new models of water governance that include non-conventional water sources in place in Mediterranean areas. Hello? Is there any problem? Please let me know.
Giulio, non si sente bene, prova a togliere il video.
Okay, so I'm quitting the video. Without the microphone, because usually microphone is a little bit. Is it better now?
Yes, it seems so.
Is it better now? Can you hear me?
Yes, yes.
Yes.
Perfect. So now, finally, I mean, we are doing these activities to do participatory models and new governance models, basically to have a better application of European water policies and national water policies for the south of Mediterranean, and to have this solution really in place. We have 4 living labs. In Spain, the Segura Basin. In Italy, the Orcia River Basin. In Egypt, the Wadi Nagamish. And we have also a transboundary watershed between Tunisia and Algeria, which is basically Wadi El Kebir on the border. This is our methodology. So the methodology is basically based on the testing of non-conventional water management in different living labs. The living labs, they are basically centered around the 4 case studies. And you see that basically we have multiple rounds of participatory modeling. So basically what we are doing is to work in the living labs and then to have basically a feedback loop between the living labs, so what we are doing involving stakeholders, and basically the models. So we are modeling multiple times our watershed with the input of the stakeholders and have a feedback. This is very important for the masterclass because it's here where the SWAT model comes in. So we are using the SWAT model for modeling these case studies. After multiple rounds of participatory modeling, and you see here the feedback, what we aim to is to have basically a new governance and new policy models, and also to have a reliable hypothesis on how well this policy will work because we have the models. Also, we are trying with a different approach to create a new crop allocation map for the Mediterranean area. But this is outside the topic of the masterclass of today, but you can find more information on the site. Which are our key exploitable results, our main goals. So the first one is to define an innovative modeling and optimization procedure for different models, including non-conventional waters. And this is something that will benefit firstly researchers, but also decision makers. Then we want also to use the participatory modeling to produce innovative watershed management plan that includes a transboundary case, and these results will benefit all the administration and the governments working on these case studies. But also what we want to do is to prepare policy documents for upscaling and outscaling the use of non-conventional waters at the Mediterranean scale. And this objective, this result, will benefit at the larger scale policymakers and institutions in the Mediterranean. I invite you to follow our project in the website. We have also quite an active Twitter account and a Facebook account. So for updates, just go there and you can follow our activities. So this is the final page, and I told you we really thank the Prima Foundation and the European Union for the support. And our team is available for any request you may have later on. So thank you very much, and I'm going to stop the screen sharing. Now we will start with the first presentation. Just before that, a very quick list of engagement rules. So first of all, we will have 3 presentations of 45 minutes and 15 minutes break. So you will have time to really take stock of the information. We will have several breaks. Second of all, this is a masterclass with quite a lot of people. So in case you downloaded the SWAT Plus model and you are doing the exercise, we feel that there will be no time to make a debug or to check your errors. So just in case, drop us an email, because we are 70 people and we are online, so we will perform a demonstration. And third of all, maybe we will have some time for questions, specifically in the third session, because it will show a little bit also some applications of the model. But during the lesson and during the masterclass, please keep your microphone muted. So that's all on my side, and I'm leaving the floor to Lorenzo for his presentation.
Good morning, everyone. I'm Lorenzo Villani. I'm a PhD student, and I am in charge of this first session of this masterclass that is about setting up the SWAT Plus model. I hope you can see everything. I will start introducing the SWAT model, and then I will also introduce the interfaces that we are going to use. And then I will describe the data that we are going to need to set up the model. The presentation will be quite short, and then I will do the demonstration with the aerobic exercise. I will set up this example dataset model that if you downloaded the SWAT model, you already have it in your computer. So the soil and water assessment tool was introduced in the early 90s after the combination of previously models. And since then, it was applied in several different fields, ranging from hydrological to water pollution, erosion, climate change, and crop yield simulations, among others. It is used everywhere. There are over 4,300 SWAT-related publications, and a recent literature review for the Mediterranean area found 260 papers applying SWAT or SWAT+. It is applied at different scales, from the field to the continental one. And a very interesting feature of this model is that it has a large community of users that produces many useful tools and also facilitate SWAT applications, because basically the problems that we are facing in our setting up or in our simulation were already faced by other researchers. This is often the case. So SWAT is an integrated, continuous time, semi-distributed, process-based river basin model that operates on a daily time step. The water balance is the driving force of the model, and the watershed hydrology is represented by 2 phases, the land and the routing phases. And SWAT is computationally efficient, but at the same time, it maintains a good level of discretization of the watershed. And this is user-defined. Basically, the user can decide how many spatial units to create. And we are going to see an example after with the aerobic dataset. And to be computationally efficient, SWAT simplifies many processes, and therefore they are sometimes broadly represented. And if you need some more specific representation, for example, of groundwater, you might need to couple it with some specific model or to directly use other models. SWAT Plus is a revised version expected to improve the code maintenance and provide a better representation of the spatial units. especially after the introduction of landscape units. Another very interesting features introduced with SWAT Plus are decision tables that represent complex land management and reservoir operations based on simple rules. In this slide, I'm showing you the spatial units used in SWAT Plus that for the large part correspond to the ones used in SWAT, with the exception of landscape unit. So the watershed is composed of multiple subbasins that are area draining into a stream reach. The stream reaches are sections of the stream network between significant points. Channels are finer divisions compared to the streams and allow us to place watershed components such as landscape units, reservoirs, and hydrological response units. Landscape units are regions draining into channel reaches, and this can be divided into floodplain and upslope regions. These regions are formed by single landscape units. And finally, the smallest spatial unit in SWAT and in SWAT Plus are the hydrological response units that are a collection of pixels that are within a landscape unit, and they share the same land use, soil, and slope range. In this masterclass, we are going to use these three interfaces, QSWAT Plus and the SWAT Plus editor in this session, and the SWAT Plus toolbox in the second session. And if you download the model, you should have these three interfaces already installed, because these are the ones that are suggested by the developers. But of course, especially for the third one, the SWAT Plus toolbox, there are other options to perform calibration, sensitivity analysis, and so on. So the QSWAT Plus is a QGIS interface for setting up the watershed. The SWAT Plus editor is a user interface for modifying SWAT Plus inputs and running the model. And finally, the SWAT Plus toolbox is a user interface for performing sensitivity analysis, calibration, and more. So to set up the model, we need a number of input data. We need a digital elevation map. We can also use streams. These are very useful, even if these are optional. We also need to know where the outlet is. We can have a shapefile with a point where the outlet is or where the outlets are, but we can also draw this on the map. Then we need the land use maps, soil maps, and climate data. And finally, if we want to calibrate and validate our model, we need observations. So this is the input data directory that if you have the model again, you should find in the example dataset inside Robit. And you have raster files with digital elevation model, land use and soil. You have shape files. You have climate data, observations, and then you have a series of CSV files. And these are databases, also default databases, but you can also modify this if you want, plant and urban. And then you also have lookup tables for land use, for soil, and user soil. And here we also have weather generator statistics. We are going to check them during the exercise in a few minutes. So before that, I wanted to tell you something about these input data. The maps must have the same projections, and these usually are UTM, something that approximate equal area projections. We also have need lookup tables that are CSV files to convert from the numeric values to the SWAT Plus land use codes and soil names respectively. We also need for the soil, the user soil usually, if you're not using global datasets, to define the soil properties. And finally, we might want to do a weather generator. A weather generator is needed to fill the missing data using monthly statistic. There is already one that you can download together with SWAT Plus that is based on CFSR climate dataset. But the user can also prepare one if you want to have a more specific one. So soon we are going to set up the model following the AG-WaMED Plus manual version 2.4. You also have this in your folder if you have this. I will go as low as possible, but we have like 30 minutes and I wanted to tell you quite a number of things. So I won't be that slow, unfortunately. In this presentation, you can find references and other useful links. And of course, you can contact us whenever you want. So I will stop the presentation and I will start opening QGIS. And the first thing I wanted to do is to show you a little bit the folder, the directory that we were talking about is the example dataset. You should have it. It is inside Robit. And here you have it all, the climate, the DM, and so on. If we open the climate, we can see how these how the files are prepared here. We have 5 text files, basically, one for each climate variable. So we have relative humidity, precipitation, solar radiation, temperature, and wind speed. And each one of them is prepared as this with some characteristics. It's basically a CSV file. And the most important one is the name. I mean, of course, also the location is important, but now we focus on the name. Here there is only one station, but there might be more than one. So the name of this station is Rob PCP. And in the same folder, you need to have the Rob PCP station with all the climate data daily. So the first one is the date, and then you have daily observations for all the years that you need. And this is it. When you have no value, you need to put -99. And then the weather generator will work with the simulated data. So we have the DEM. We can open it in QGIS. We can see that it works. The projections are UTM-like 32637. We can see that everything works. We can also open the land use, for example. We can open these, and here we might want to change the properties. We can classify again, click on OK. So here you see that the light blue land use is by far the most represented. And here in the legend, you see that it is the number 2. Then we have also number 1 here, that it seems like a lake, it seems water. And then we have other land uses, the 3 and the 4. But we don't know which one, how these codes are related to the SWAT codes. And to do that, we need to check the land use lookup table. We can open it. You have seen that we have it. So we have the number 1 is water. Then the second one is agricultural land. This is the code for agricultural land. Then we also have pastures and we also have forests. So we can see from the land use that the largest part of the watershed is covered by agricultural areas. We can do the same for soil. We upload the soil. And we see here, maybe like this, the soil layer is much bigger. And this is really not a problem. The only map that you need to clip to your watershed is the DEM, because this is when how you can make it as fast as possible, your model. The other raster files will be clipped to the watershed.
Idea.
So we can, for example, see the kind of soil, the main kind of soil here in our watershed. We can click on information and it is 108. And of course, again, we can check the lookup table for soils, which is Robit soils. We can open this, and the number 108 is LVX here. But this is just the name of the soil. To check the characteristics, we need to open the user soil. We have to find the 108, which is this one. And here you have all the characteristics with the user soil. Very quickly, these first columns are general characteristics of the soils. For example, you have the number of layers, you have the total soil depth, and so on. Then this file is organized based on layers. These, when there is one in the column name, it refers to the first layer. And so here the first soil depth is 25 centimeters. Then you have also bulk density, available water capacity, and so on. And after that, we have the second layer, which is this one, with the same characteristics repeated. And then the third one. And in our file, we have nothing for the fourth layers because we have no soils with more than 3 layers, as we can see here. So this sometimes is confusing, but once you understand how it works, it's not so difficult. And also usually you will use global user soils, and therefore you won't need to prepare one. So we also have other shapefiles here, but we are going to see them while we prepare the exercise. And so we are just going to start the exercise. So you should have an icon here, the SWAT plus icon, if you have installed, of course, the SWAT. If you don't have it, you should go to plugins and search for SWAT, and you should activate SWAT plus. Then we can open it, and we can decide if to start a new project or use an existing one. In our case, we are starting a new project, and it asks us to create, to select the folder where we want to create the project. I'm going to select one folder, and I'm just going to write a name, AG-WaMED Masterclass example, for example. I click on OK, and you can close this. Sometimes it does this. And we can see that there is the first step when we can delineate the watershed. We can click on it. And now we can start with the delineation of the watershed. That is the first step. In the first part, it asks us to upload the DEM. We can click on the 3 points, and we search for SWAT plus example dataset, AG-WaMED DEM, and then we open our raster file. And here it is open correctly. And you can see that the next step is the creation of streams. These are, there are 2 thresholds that we need to set, the channel and the stream thresholds. There, we can start using the default ones that usually are very reasonable. And these thresholds are defined as the minimum number of cells required to create a channel or a stream. But it's better explained if we try to create the streams now. This process will take few seconds here, but sometimes it takes much longer according to your computer and to your model and the resolution of the DEM. So now we will see the streams and the channels. Here you have the streams and the channels, they were created. And for example, these in light blue are the channels that are finer divisions, while these are the streams in blue that are less detailed. And for example, we can see the difference if we write, for example, a lower threshold with 20 and 100, and we can look at the map and see the difference here after creating the streams. And this is what I was referring to during the presentation, that the user can decide the level of discretization of your watershed. And this is basically where you do this. For example, in our study case in Italy, we are going to place a lot of small reservoirs, and therefore we really need to minimize this channel threshold so that we can place these reservoirs on the channels, because reservoirs has to be put on channels. So you see here, there are much more streams and much more channels. You might have noticed that we didn't burn in any stream network, but we can do it since we have them. So we go back again to our folder. We search for Rabbit streams and we add Rob Rich. We click on OK. And we can change the color maybe. Yeah, now it's a little bit. Now you see it, you should see it. And we can compare the streams with the observed streams. And we can see that upslope, more or less, they correspond. But in the floodplain near the lake, this doesn't really correspond that well. For example, here there is a stream, but this is our observed stream. So if we repeat the process, we can create again the streams with this clicked. We can create the streams. And now we can see that it changed. It will change if everything works. And after this, we can consider the stream delineation completed. Then we will have to select or draw or input our outlet shapefile. So you see that here the streams change, and now they are much more corresponding to the observed streams. So we can move on. We can, as I was telling you, we can draw the outlet with this interface here. If you click on the map, we can draw the outlet. We can also draw reservoirs or ponds. But since we have a shapefile with the outlet, we are not going to do this. So I click on cancel and I click on the 3 points and I add the main outlet shapefile. And now you can see it, that it's appeared here. It is not exactly on the streams, but this is okay. Also because it is not that far, we can measure this. It is a little bit less than 4 meters, if you see here. And SWAT will place your outlet on the stream network based on this NAP threshold. So just for example, if we put a number shorter than 4 and lower than 4, we can try with review snapped, and we see that it gives us an error because it could not snap. But if we increase this snap threshold, we click on review snapped, and now it was placed on the stream. So now we can create the watershed. We have everything that we need. We have the streams and we have the outlet. So we click on create watershed. And now it will take again some time to create the watershed. Okay, more or less it's finished. We can see that we have our subbasins. We have quite a number of them because we use the quite low thresholds. We can, of course, open the subbasins here layer, and we can open the attribute table. And we see, for example, that we have 87 subbasins. There is quite small. And in the subbasin, the column, there are no values. And this is because this file is still temporary, it's not permanent one. So I just wanted to repeat the process again very quickly by setting more or less the default thresholds. and create the streams. And I wanted to show you that we can, of course, reduce the number of basins. And this is again according to your needs. So we create the streams and then we create the watershed. And after that, we almost completed this delineation. We can also add lakes if we have a shape file with the lakes. We can merge the subbasins if there is one if there are small ones that we don't want to consider. And then we can also create landscapes. Okay, so here it is. Here we have our new subbasin delineation. We can open again the attribute table, and now we see that we have 9 subbasins. Again, this is a temporary file. So we can create this landscape, and these will be used in the second step to create the landscape units. So it is very important to create them. We can click on create. And there are 3 methods. We are not going to describe them, but we can create them all and see the different. We can use different thresholds. And what they suggest is to create a number of floodplain with different threshold, with different methods, and then to compare them with the observed floodplain and to choose the ones that better approximate the reality. So this is by buffer, this is by inversion, and this is by branch. And in the manual, they suggest to use this one by inversion, so we are going to use this. So we finish this, so we click on OK, and everything will become permanent. So we can open, for example, the attribute table of subbasins, and now we see that the subbasins are numbered. So we can proceed now. We go again the tool, and we can proceed with the second step, that is create H areas. So we click on it. We have to add here the land use map. We know where it is. It is here in land use HDR. We select then the soil map. That is here. The third one, we can keep it as default. And then we need the user soil. We need to click on the user soil. And the other 2 are for US soils. So we are not going to use them. We need to add the tables, the land use lookup. We have to click on CSV file because we're going to add it. It's Rabbit land uses. The soil lookup is Rabbit soils. And the user soil is Rabbit user soil. So we have all of them. Here we can also add again the databases of plant and urban, and this contains the codes that are in the land use lookup. But these are the default ones, so we can just keep them as we want. And we might also want to select the floodplain inverse flood. And for the moment, I will just read this. I will click on this generate full HRUs file. That is very useful to analyze the HRU creation. So we can click on this and we can click on read. It will create our HRUs. It is quite quick in our case. So we can see here some numbers. We have 9 subbasins. We have 103 channels, and we have 333 HRUs. We can, of course, inspect our landscape unit file and our full HRUs layer. So, for example, we can open these. Here you see that for each channel, 14, for example, there is 1 upslope and 1 floodplain. These are single regions, and this is the same for all the channels, 21 and so on. You can also see them if we remove this. So these are this, for example, is upslope. This is a landscape upslope, a landscape unit upslope, and this is a landscape unit floodplain. And basically every channel has them. So this is upslope and this is floodplain. And it's based on the raster that we used as input. We can also analyze the full HRUs file to layer to see how it is prepared. Here we see that for subbasins 1, for example, for channel 14, we have 2, 3, 6. We have 6 different HRUs, 3 upslope and 3 floodplain. And the combination of landscape, land use, soil, and slope is unique for each channel, of course. And then you also see other characteristics like the percentage of the landscape. And here in the HRUs, you see that there is nothing because this is again temporary. You see that there is only one slope band because we didn't specify anything. So we will do it in a while. But first we might, let's create new HRUs. If you want to create new HRUs, you can click again on read maps. And for example, we want to add now a slope, 2 slope bands. So we add 10, for example, here we click on insert. And now we have 2 different classes for slope, less than 10 and more than 10. So we can click on read here and you can see that the full HRUs count will increase quite a lot. We click on read. And here we have 583 HRUs. So we can inspect the attribute table again. And now we see that we have the slope band. We have 2 classes. And for example, for channel 14, now we have 10 HRUs, 6 for upslope, and 4 for floodplain. So we can have a look at them also. For example, this is one very small HRU. It is only 1 pixel. And in some cases, we might want to exclude it because it's very small and it will increase the simulation time without having too much influence on the processes. And this is, for example, a bigger one that is close. And here you have in yellow the HRU, the third HRU that is quite big. And I think it's very important that you notice that this is not a single polygon, but it is the collection of pixels inside the landscape unit. So inside this landscape unit, all the pixels that share the same land use, soil, and slope are put together in the same HRU. So we can continue, I think. The next very important part is to remerge the short channels. This is usually done because there will be a number of small channels. And again, this is a little bit like the small HRUs. And we can eliminate them. Usually we select a threshold of 2%. Of course, you can change it, but this is more or less the default value, I would say. So we click on remerge short channels, we put here 2 and we click on the read and we will see that the channel count and the full HRU count will decrease. So now we have 87 channels and we have 522 HRUs. So now we finished with this tab and we might go to the second tab, that is HRUs here on top. If you have an older version, this might be a little bit different, but it has the same options. So you go to HRUs, and here there are 2 options. One very interesting one is to split the land uses or to exempt the land uses, but you're not going to talk about these ones here. And it is very important that if you're going to use the SWAT model, that you understand these filtering methods, especially the difference between single and multiple HRUs. If we select one method, such as the dominant land use, soil, and slope, or the dominant HRUs, we are going to create one HRUs per each landscape unit. So we can try this. We can see an example. We can create the HRUs. Now we see that there is a new shapefile was created. And this is a permanent one, is actual HRUs. And you see that there are a lot of holes because we selected a lot of HRUs. We excluded a lot of them. We can, for example, open the attribute table now. You see in the HRUs that we have the numbers because now it is permanent. And you see that for each landscape unit, there is one HRU, and for each channel, therefore, we have 2 HRUs. So for channel 14, we have 2 HRUs, and so on for all the others. And the percentage of the landscape is by definition 100 here. So this is an option. Of course, it's not wrong, but usually I maintain a higher number of HRUs. If we want to repeat again the process, we can click on read from previous run. So we repeat the process, and it doesn't really take much time now. We can go on HRU, and now we can select the multiple HRU methods that are filtered by land use, soil, and slope, filtered by area, or the target number of HRU. Now I think we are going to use the filter by area, and we can decide one threshold method. And I usually put 0. If you put 0, you will keep all your HRUs. This sometimes can be the case, but again, you have to decide this. Is part of the choices that you will have to do while preparing your model. So we can click on create HRUs. And now we will see that the shapefile actual HRUs won't have any hole. So now we can open these, and again we can check that for channel 14 we have 6. We have a total of 10 HRUs for channel 14 with 6 upslope and 4 floodplain, and we also have our very small one that was maintained here, and also the other one, the third one that again it was maintained. It is the same. And if you are happy with this configuration, we can continue. In this case, we are. So we can consider concluded the second step. And now there are, just wanted to mention these reports to you that might be very useful to have the information that you've used to prepare your watershed. But now we are going to click on step 3. That will directly open the SWAT Plus editor. We click on edit inputs and run SWAT Plus. And it will directly load our project, and it will open this with this SWAT Plus editor. We can change the name, but we don't want to, so we click on start. And again, it will import everything, and we will have a nice summary with all the information of our project. Example, here we see that 88.9% is agricultural land, as we saw. There is also pasture and also forest. Here there are all the characteristics, 86 channels, 520 HRUs. And this SWAT Plus editor, the only thing that is mandatory to do is to add the weather generator, and if you have the weather station. You can do that by clicking on Get Started, but also on going to this pen here. You can click on Edit SWAT Plus Inputs, and you can go on Weather Generator. And here we can go on Import Data to import our weather generator. So as I was mentioning, we can use the default one or the ones that we have. We will try both of the methods. So we leave database here, and you see that the CFSR is the climate dataset. We have to check this because we are going to use observed weather data, and we click on Start, and it will import our weather generator based on this dataset. And here we see that we have 9 rows. But we saw that we have two CSV files that represent the weather generator, so we can click on two CSV files. That is the station CSV file, and we can look for it. This one, wgen-robit-stat. We can open this. Then we can open the wgen-robit-mon. Here we have to delete the existing weather generators and, of course, keep it checked. We can start, and now it will import only one weather generator, the one that we prepared. And this is it. We can then move to weather station. And to add the weather station, we have to go on import data. We click on import data. Here there are two formats, SWAT 2012 and SWAT Plus. Our format is SWAT 2012. And we have to select the files, the climate robit directory. We select the whole folder. We click on select, and we can just click on start. And it will import our only weather station. We have only one weather station, and as we saw before, to this it was assigned our weather generator, and we can open all these if we want. Just wanted to show you that this is the SWAT Plus format, while this was the SWAT 2012. That is the one that we had. This is the SWAT 2012, and it will directly transform it. So here it is. Before running the simulation, I just wanted to show you that you can do a lot of things here. You can modify the settings. For example, for the codes, you can select the potential evapotranspiration method. Now it's Penman-Monteith. We can select Priestley-Taylor, Hargreaves, and so on. We can change a lot of things. And we can change the management, the operations of the reservoirs, if we have them, decision tables. And we can also modify the soils or the databases themselves if we want. So we can, now we are not doing anything of this, and we are going to run SWAT Plus, clicking on this triangle. So we can keep the first one as it is. And in set your simulation period, you will see that the dates are taken from your climate data. Now we have 24 climate data. We might want to decrease this to make it a little bit quicker. We can put 94 as ending date. We can close this. And then we can choose the outputs to print. So first of all, there is the warm-up period, and very briefly, this is the time in years where SWAT will simulate, but the outputs won't be printed, so the results won't be analyzed. And the more complex the model is, the more years you should put here. But of course, this also depends on how many years you have in your climate observations. So for this case, I will remove all the yearly outputs. These are the outputs that we want to print. And we are going to print only the channel monthly. And I will run everything. I save setting and run selected. And so SWAT at the beginning will write these input files. Then it will run the model. It is already running the first year. And then finally it will write the outputs. And if we have these clicked, analyze output for visualization, it will allow us to see them with the QSWAT Plus toolbox. I will very quickly show you that since we have a couple of minutes. So now when this simulation ends, this is super quick. I mean, there are some cases it takes like many minutes for one single year, but now this is very quick. And now it's writing the outputs. And the SWAT plus editor will ask us what we want to do now. We can run the SWAT plus check. That is a very interesting tool to check if our outputs are reasonable. We can directly open the SWAT plus toolbox, and you're going to do this in the next session. Then we can save the scenario. But now I wanted to show you this SWAT plus check that is inside the SWAT plus editor. If you go on hydrology, for example, there are a lot of sections here, depending to the one you're interested in. And here there are figures and tables that you should try to see if they make sense. And there are also message and warnings that you might want to read to check if everything makes sense. So the last things I wanted to show you is that now we can, we have the step 4 here, we can visualize the results here with the QSWAT plus, but we're not going to do this. The other thing that I wanted to show you is the project folder that we created. We created this AG-WaMED Masterclass example. We can open this. And this is the QGIS project. If you saw, I didn't save it, but if I open this, it will directly open it again. So you don't need to save your project in QGIS. You can open the watershed, for example, and here you have rasters, shapes, and text. And but what I wanted to show you is inside scenarios, inside the fold. The text in out folder is the one that we are more interested in. Now I'm copying the executable file here. And in this folder, there is all the input and all the outputs. For example, we can see the basin water balance annual average output file. All these files can be opened with Notepad. And here, for example, you see all the annual average, the precipitation, the water yield, percolation, and so on. So you can also use these to analyze your outputs. But here there are also the inputs. So for example, this is a very nice one, print.prt. Here you can decide which outputs to print. It is quite similar to the previous SWAT plus interface. But we can also print the CSV files. We can do this from the SWAT plus editor, but now I'm doing it here. I just put the Y and I click on save. And I will slightly reduce the simulation time, clicking on time. I will put 1992. I will save this. And I will run the model just to show you that we can do it like this. And this is just another option. It is much quicker, but of course you need to know what you are changing because it might be a little bit dangerous if you have not clear which inputs file you are changing. So the model has already finished and we will have CSV files to analyze. And with this, I am a little bit longer on time, but I hope you enjoyed this presentation and this exercise. And if you have any question, you can contact us, of course, and I will leave the floor to Giulio or for the break.
Thank you very much, Lorenzo. Actually, we are a little bit over time. There was one thing that I think it was useful, and then I will leave the floor to Ismail, and maybe we can do some questions at the end. Where are the files located? The files that you use for your exercise? Just to show.
I can share it again. If you install the SWAT with the default options, they are in your C. Then you should have a SWAT folder, SWAT directory. Then SWAT plus, there is only this one. And here you have everything. You have the databases, you have the documents in the documents, you have the QSWAT plus manual, if you decide to download it. Then there is the example dataset here, and there is the ROBIT, and you have all the
okay, so just to clarify, when you download and install the program, it's also putting in your C folder the database that we are using for this exercise. And the exercise that Lorenzo showed is also visible in the user manual. So it's fully documented. So they did the first step. I believe the second lesson of the masterclass will be rather more technical on calibration and validation, and maybe more advanced. Maybe you will need to see it a couple of times. But yes, so that's where the files are. And again, I'm telling this for everyone, the recording of the masterclass will be available on our YouTube channel, and the slides will be available on our website. If you go there, there is already the first masterclass, so you can see how everything will be released. So actually, I don't know if anyone has questions, but honestly, I would set up a break of 10 minutes, and we meet at 10:30 with the second section. So thank you very much. I'm going to interrupt the recording, and then we will have another one.